Picture the Earth as an egg, not a hard-boiled one, a raw one. The shell is the crust, and it is shockingly thin. Everything humans have ever done, every city, every war, every birthday party, happened on that fragile outer layer. And underneath it, heat. Staggering amounts of heat. That heat is the whole story of volcanoes. So before getting to the lava and the explosions, the real question is, why is the inside of the planet hot in the first place? Two reasons. First, leftover heat from the planet's birth. 4.5 billion years ago, Earth formed from countless rocks slamming together, and every collision converted motion into heat, like a hammer striking an anvil over and over for millions of years. Gravity compressed the growing planet too, adding even more heat. Much of that heat got trapped inside. Second, radioactive elements deep in the Earth, things like uranium, thorium, and potassium, are constantly decaying, and decay releases heat. So the planet is essentially a giant, slowly cooling ball with a nuclear space heater running in the basement. Now, heat wants out. That's just physics. Hot stuff rises, cool stuff sinks. Inside the Earth, rock that seems solid to us can actually flow, incredibly slowly, like warm asphalt, churning in giant loops. And that churning helps push around the broken pieces of crust floating on top, the tectonic plates. Here's where volcanoes come in. A volcano is not a mountain that happens to have fire in it. A volcano is a leak. It's a spot where the planet's inner heat found a weakness in the shell and punched through. The mountain part is just the debris pile that builds up around the leak over time. Most of these leaks happen in predictable places. Where plates pull apart, like the mid-Atlantic, molten rock rises up to fill the gap. Where plates crash together, one plate gets shoved down into the hot interior, and here's a lovely detail. It carries water-rich minerals down with it. That water lowers the melting point of the surrounding rock, the same way salt lowers the melting point of ice on a winter road. The rock melts, becomes buoyant, and rises. That's why the Pacific is ringed with volcanoes, the famous Ring of Fire. It's basically a seam line on the planet. And then there's the wild card. Hotspots. Plumes of extra hot material rising from deep down, bore torching through the middle of a plate. Hawaii is a hotspot. The plate slides over it like a sheet of paper under a candle, and each scorch mark becomes a new island. Now, the close-up view. Why do some volcanoes ooze gently while others detonate? It comes down to two things: how gooey the magma is and how much gas is dissolved in it. Runny magma lets gas bubble out easily, so you get Hawaiian lava fountains. Dangerous, but polite. Thick, sticky magma traps gas under pressure. Shake a soda bottle and cap it. That's a stratovolcano. When the cork finally pops, the eruption can blast rock, ash, and superheated gas outward at terrifying speed. Pyroclastic flows, racing clouds of hot gas, ash, and debris are what buried Pompeii.
If you enjoy these videos, do check out our mobile app. Treehorn makes audio shows like this every morning. We also cover tech news, politics, entertainment, and more. Treehorn is available on both iPhone and Android.
And then there's the extreme end of the scale, supervolcanoes. These don't even look like mountains. They're vast underground reservoirs of magma, so large that when they erupt, the ground above them collapses into a crater called a caldera, sometimes dozens of miles across. Yellowstone is the famous one. It's not a peak, it's a hole, a scar from eruptions thousands of times bigger than anything in recorded history. A supervolcanic eruption can throw enough ash into the sky to dim the sun and cool the entire planet for years. The good news is these events are incredibly rare, separated by hundreds of thousands of years, and scientists monitor the known ones constantly. But they're a humbling reminder of just how much power is sitting under that thin eggshell. Here's the twist, though. Volcanoes aren't just destroyers. They're arguably why anyone is here to talk about them. Early Earth's atmosphere and much of its water were burped out of volcanoes. Volcanic soil is absurdly fertile. Ash is loaded with minerals, which is why humans keep farming on the slopes of active volcanoes despite knowing better. Millions of people today live in the shadow of a volcano, essentially betting their lives on good soil. And humans have found remarkable uses for volcanoes beyond farmland. Obsidian, volcanic glass formed when lava cools too quickly to form crystals, became humanity's first precision tool. Obsidian blades can be sharper than modern steel scalpels, and ancient people traded the stuff across enormous distances. Obsidian was also polished into mirrors, and these weren't just for checking your hair. In ancient Mesoamerica, obsidian mirrors were sacred objects, used by priests for divination and associated with gods like Tezcatlipoca, whose name literally means smoking mirror. One famous obsidian mirror even made its way to Europe and into the hands of John Dee, court astrologer to Queen Elizabeth I, who used it to try to speak with angels. And today the relationship continues. Geothermal plants in Iceland tap volcanic heat to warm homes and power cities, literally plugging civilization into the planet's leaky shell. So, the next time a volcano shows up in the news, remember what's actually being watched. A pinhole leak in an eggshell, venting heat that's been trapped since before the moon existed. The mountain is temporary. The heat underneath has been trying to get out for 4.5 billion years. And it's not done yet. That concludes today's video. Holy moly, that is a lot to take in. So you're telling me all of Earth is basically molten lava, and you expect me to just go on living my life? We'll see about that. Until next time, friends, have a wonderful day.